You'll recall from Algebra 1 or Algebra 2 or pre-calculus that a sequence is a list of numbers, and a series is just the sum of that list of numbers. So we're going to talk in this section about an infinite series. Well, you might guess, as you might guess, an infinite series is just a series that goes on forever. So if we have to add up an infinite number of terms because there are an infinite number of terms in our sequence, we have what is called an infinite series. In this case, A1, A2, A3, those numbers are called the terms. When my little subscript is n, I say that is A sub n, and that represents the nth term of the sequence. A partial sum of a series is just the sum of less than an infinite number of terms in the series. So the first partial sum is just the first term. The second partial sum is the sum of the first two terms. The third partial sum is the sum of the three terms. And we could say the nth partial sum is the sum of n terms. If, as n gets bigger and bigger and bigger, that sum, s sub n, approaches some value that we can narrow down, that we can find a limit for, then we say the series converges. If there's no limit of those partial sums, then the series diverges. So for example, I listed an example on your paper of the series 2 plus 4 plus 6 plus 8 plus ... So the first partial sum would be 2. The second partial sum is 2 plus 4 is 6. The third partial sum is 2 plus 4 plus 6, which is 12. The next partial sum, 2 plus 4 is 6, and 6 is 12, and 8 is 20. So does it seem like there's a limit to this sequence? So the limit as n went to infinity of this a sub n. Is there a limit? No. So this sequence, this series, 2 plus 4 plus 6 plus 8 plus, diverges. It does not converge. We're going to try to focus in this section. Well, what we really want to work with in calculus is series that converge. So we're going to spend some time in this section being able to tell when a series converges and when it diverges. All right. Actually going to go to your assignment. So this is the first example. This series, 1 minus 1 plus 1 minus 1 plus 1, ... Does it converge? So we said a series converges if the sequence of partial sums has a limit. So I'm going to make a list, I'm going to make another sequence out of the first term, comma, the first two terms added together, comma, the first three terms added together, and we're going to see if there's a limit. So when I do that, I get, if I took just the first term of this series, I would get 1. If I added the first term and the second term, I'd have 1 minus 1 is 0. If I added the first three terms, I'd get 1 plus negative 1 plus 1, which is 1 again. The sum of the first four terms is 1 minus 1 plus 1 minus 1 is 0 again. And you can see that this sequence of the partial sums is just going to alternate between 0 and 1. So my question, does this sequence have a limit? As n approaches infinity, can I tell what my sequence value, my term value, is headed toward? And the answer is no, I can't. It's alternating back and forth between two values, so there's no limit. So there's no limit, so this series does not converge. This next one, 3/10 plus 3/100 plus 3,000 plus 3/10,000 plus ... Does this one converge? So I'm going to make the list of partial sums, and we're going to see if I can tell what I'm headed toward. So 3/10 is 0.3. For the second partial sum, I would add 3/10 to 3/100, and that would be 0.3 plus 0.03, which is 0.33. The sum of the first three terms is 0.3 plus 0.03 plus 0.003, which is 0.333. If I add the first 4 terms together, I'm going to get 0.3333. So can you tell what my partial sum is approaching as I add more and more terms together? And I think we can all agree that we are approaching I'm going to go ... 0.3 with a bar over it, and we know that that is equal to 1/3. So if I could name some value that my sequence of partial sums is approaching, then the series converges. So this series does converge. It converges to 1/3. We're going to learn more about this series in a second. So we said one of our big focuses in this first section is to tell whether a series converges or diverges, because moving forward in Chapter 9, we want to focus just on series that converge. So there's some series we can tell right away are going to diverge if the terms in the series, meaning the same thing as the terms in the sequence that you're adding together, if those terms do not approach 0, if the limit as n goes toward infinity of the nth term is not 0, then there's no way that the series will diverge. Sorry, there's no way that the series will converge. The series will diverge. So, for you to even consider the possibility of a series converging, the limit of the terms must be 0. Okay, so what we want to do now is remember some things we know. There's one kind of series that you've probably talked about in your Algebra 2 class, your pre-calculus class, and that's a geometric series. That's going to be your best friend in Chapter 9 because there are very specific rules for when a geometric series converges. A geometric series, a geometric sequence is a sequence in which the next term is always found by multiplying by the same value. So here, if I have a first term that's a, and the next term is a times r, that means r is the number I multiplied by to get from the first term to the second term. So if I multiply by r again, my third term will be a times r, or ar squared, and then a r to the third, a r to the fourth, until the nth term is a times r to the n minus 1. R is typically referred to as R is the ratio. R is the number that you're multiplying by every time, and just by convention, we do refer to that as R. So people would know what you were talking about if you just called it R, that number you multiply by. The thing about a geometric sequence is that if you turn it into a series by adding together all the terms, that series will converge as long as R is between -1 and +1, not inclusive. So this statement here, the sum of that infinite geometric series will be the first term, a, divided by 1 minus r, 1 minus that ratio that you're multiplying by, which is going to be really convenient, and that works as long as the absolute value of r is less than 1. So this statement, the absolute value of r is less than 1, that's a shorthand way of saying -1 is less than r, which is less than 1, which you can see here. So that's called the interval of convergence. The series will converge as long as r is somewhere between -1 and +1. You must memorize this expression for the sum of an infinite geometric series.